Welcome to the Twin Labs podcast, where we help you make better decisions using AI and digital twins.
And welcome to the deep dive.
So today we are really getting into something that I think is at the heart of, well, a huge problem for businesses everywhere. We've all seen it. Companies are pouring millions into, analytics, these massive data lakes, BI dashboards, and yet there's this painful truth they're all discovering.
They're drowning in data.
Exactly. Drowning in data, but completely starving for actionable insights. It's like having a library full of books, but no idea which one to read.
That's a great way to put it.
Yeah.
Because traditional business intelligence, what most companies rely on, is really just a rearview mirror.
A rearview mirror tells you what happened last quarter, maybe.
Right. Or it can help you diagnose why a machine failed after the fact. But the companies that are actually leading, the ones that adapt and move fast, they need something totally different.
They need to know what's coming. They need to know what to do next.
That is the gap. That inability to get from analysis to execution, that's probably the biggest source of waste and inefficiency in a modern company.
You spend all this time and money on these beautiful reports. Right? The trend lines are clear, you get the causality, but then what?
Then what? It becomes a huge manual effort to turn all that complex, often contradictory data into, a single prioritized action plan.
And that's where human delay, silos, cognitive bias, all of that creeps in.
That manual step is the chasm.
Yeah.
And that's what we need to cross.
And crossing that chasm, that is the mission for our deep dive today. We're going to be exploring a really, I think, transformative solution that's coming from Twin Labs. It leverages something called AI twins and these proprietary decision intelligence models.
And it's an interesting story, too, coming right out of Durban, South Africa. This approach is unique because it's not just about, mirroring what's happening.
It's not just more data.
It's not more data. It's about embedding intelligence that actually guides you, helps you execute, both strategically and on the ground, day to day.
So our objective today is really clear. We want you, our listener, to walk away with a deep, expert-level understanding of this. We're going to unpack how these technologies, and especially that core differentiator, the decision intelligence models, really redefine how an organization can make decisions.
We'll get into the architecture, look at how it applies across different industries, and really show why this isn't just another analytics tool. It's a strategic asset.
Okay, so let's start with the basics, but I want to move past them quickly. The term digital twin. Most people in industrial circles have probably heard of it. A virtual replica of a physical thing.
Correct. It's been around for a while.
But the term we're using here is AI twin. So what's the leap? What's the technical and conceptual difference that makes an AI twin different from just a standard monitoring-focused digital twin?
That distinction is absolutely crucial, and honestly, it's where a lot of people misunderstand the potential here. A traditional digital twin is, like you said, a replica, but think of it as a very, very sophisticated mirror.
A mirror. Okay, I like that analogy. It just shows you what's happening in real time.
Exactly. It tracks telemetry, the machine's temperature, fuel levels, resource use. If a piece of equipment breaks down, the twin has all the data that led up to that failure.
But a human still has to look at that data, figure it out, and decide on the fix.
Precisely. It's descriptive and maybe diagnostic. It gives you the what and sometimes the why, but that's where it stops.
So it's data points, not strategy.
Yes. An AI twin, on the other hand, is an intelligent, dynamic entity. It's a living digital replica. And its purpose isn't just to reflect reality, but to understand it, to learn from it, and, critically, to simulate ways to improve it.
So we're moving past just watching a single machine.
We're moving way past that. We start modeling the entire system that the machine operates within. That's why we call them virtual laboratories. Not for a part, but for the entire business operation.
Okay, that sounds a lot more complex. So if a traditional twin is tracking, say, a machine's temperature, what kind of context does the AI twin add on top of that raw number to get to what you're calling operational understanding?
Right. Context is everything. So let's stick with that manufacturing plant example. The traditional twin tells you machine X is running at 80 degrees Celsius. Useful, but limited.
Okay.
The AI twin knows that, but it also knows that the local utility grid is under heavy strain because of a heat wave. So your energy costs are 300% higher than normal right now.
Okay. External factors.
Exactly. And it also knows that a key component for that machine's output comes from a supplier in a region that's, currently having labor disputes. It sees the web of connections.
So it's not just, is the machine healthy?
No, the intelligence layer understands that the decision to even run machine X right now has to be weighed against these other factors: the high energy costs, the potential future scarcity of parts, and maybe the company's big strategic goal for the quarter is to maximize profit margins.
So it connects the machine's status to the company's balance sheet, essentially.
It moves the question from what is the machine doing to what is the strategic implication of this machine's activity in relation to everything else happening right now?
That immediately gets at the complexity of, modern supply chains and production. Nothing happens in a vacuum. But for the twin to stay relevant, it can't be static. It has to keep learning.
And that's the next key concept: institutional knowledge compounding. These systems are built with really sophisticated feedback loops. So every decision, every unexpected event, every outcome is observed by the AI twin.
He watches what happens in the real world.
It watches, and then it compares the real-world result to what it predicted would happen. And it uses any difference to constantly refine its internal models of cause and effect. This learned intelligence becomes an asset that just gets more and more accurate over time.
Can you walk us through a really detailed example of that? What does that compounding knowledge look like over, say, a year or two of operation?
Sure, let's take a logistics AI twin. Imagine it's managing a big fleet of trucks in a few warehouses. In year one, it learns the basics, the best routes based on distance and standard traffic data from Google Maps or whatever.
The low-hanging fruit.
The low-hanging fruit. But by year three, the knowledge it's compounded is so much richer, so much more granular.
Okay, give me an example.
First, what we call micro-route specificity. It's learned through observation that a specific intersection on, say, Route 5, only on rainy Fridays around 4 p.m., has a 40% higher chance of a 30-minute delay.
Why?
Because of localized drainage issues that generic traffic apps just don't see until the jam is already formed. It also learns which of your carrier partners consistently miss their delivery windows during the holiday rush, even if their contracts say they won't.
So it's learning the unwritten rules of the operation.
The unwritten rules. Second, inventory dynamics. It combines sales data with carrier performance and even the physical layout of your warehouse. It might learn that putting your fastest-selling items in warehouse A, even though it's closer to the customer, actually slows down fulfillment.
How could that be?
Because warehouse A's internal layout for picking and packing is inefficient. It learns that warehouse B, while further away, is the optimal place to store that stock to get it out the door faster. That's a counterintuitive insight you'd never get from a spreadsheet.
Okay, that's really powerful.
And third, predictive maintenance. It learns the specific wear and tear pattern on truck engines that do high-altitude, long-haul drives versus the ones doing short, stop-and-go city deliveries. So it schedules maintenance not on generic mileage, but on the actual stress profile of each individual vehicle. That depth of learned, embedded knowledge is what makes it a true AI twin.
That level of detail really shows the versatility. If it can model weather, traffic, and internal warehouse flows, then this must apply to a lot more than just, trucks and machines.
Oh, absolutely. The whole system is architected to model pretty much any complex system, whether it's physical, a business process, or even driven by human behavior. It's a general-purpose strategic tool.
So how do you categorize the applications?
We usually break it down into four main areas just to show the breadth. First is physical assets, the traditional stuff.
Yeah.
High-value equipment, wind farms, manufacturing lines. The focus there is all about uptime and efficiency.
Okay.
Second, business processes. This is the invisible stuff. Modeling complex supply chains, financial workflows, or even a customer service journey to predict where customers are likely to drop off.
And third.
Human systems. This is key for service industries. Think about optimizing patient flow and bed allocation in a hospital, or managing staffing in a retail store based on real-time foot traffic, or even predicting call center demand.
So systems where people are the main variable.
Exactly. And finally, complex networks. These are the huge interconnected systems where one small failure can cascade into a disaster. We're talking metropolitan energy grids, national transportation networks, things like that.
So whether you're trying to minimize a patient's wait time or maximize a turbine's uptime, the architecture is mapping the dynamics of that system in real time.
That's the foundation.
But that brings us to the big question. If the AI twin is mapping every single factor, how do you avoid just getting paralyzed by data? How do you make sure it gives you the right action, not just more information?
And that question, that's the perfect transition, because that brings us directly to the proprietary core of what Twin Labs does, the decision intelligence models.
Right. So the AI twin is the engine that creates the virtual world, but these models are the navigation system,
Yeah.
the intelligence that cuts through the noise.
That's it, exactly. This is the core differentiator. It's the competitive advantage that you can't just go out and buy off the shelf.
Yeah.
And we really need to hammer this point home. It's about the question you're asking.
What do you mean?
Traditional BI answers, what happened? Your quarterly report. More advanced analytics might get you to, why did it happen? These decision intelligence models are built for one reason and one reason only. To answer the most critical business question there is, which is,
What should we do about it?
what should we do about it? And what will happen if we do?
It's a complete shift from looking backward to prescribing a path forward.
But to do that, to tell someone what to do, the recommendation can't just be based on static rules. The right call at 9 a.m. on a Monday is probably the wrong call at 4 p.m. on a Friday.
Well, 100%. Contextual understanding is everything. If the model just gave you blanket advice, it would be useless in the real world. The whole design philosophy is to reject that one-size-fits-all logic because it knows that constraints are always changing.
So how does it manage that complexity? You mentioned avoiding data paralysis. How does it know what to focus on?
It uses a really rigorous integrated framework. It's constantly looking at 5 crucial domains of factors at the same time to make sure any recommendation is actually relevant and robust.
Okay, let's break those down. What's the first one? First is the current operational state. This is your internal reality right now. Do we have the staff available? How are the machines performing? What orders absolutely have to go out the door today? This sets the immediate baseline.
What's on the ground?
What's on the ground? Second, business objectives. This is the strategic layer. Are you trying to grow market share this quarter, even if it costs more? Or are you laser-focused on profit margin and minimizing risk? The model's priorities will change completely based on that input.
So it aligns the operational recommendation with the C-suite's goals.
It has to. Third, environmental factors, the stuff you can't control but have to react to. Market volatility, new government tariffs, what your competitors are doing, and super important granular weather forecasts that affect your logistics or energy use.
Right.
Fourth is historical patterns. The deep archive. What did we do last time demand spiked like this? What little signs usually show up right before this piece of equipment fails? That's the statistical foundation.
And the last one?
The fifth, and this is maybe the most sophisticated, is constraint networks. The models understand that a business isn't a collection of separate departments. It's a network of constraints. A decision to speed up shipping and logistics might create a huge problem for the inventory team.
Because they have less buffer stock.
Exactly. The models have to account for those trade-offs and show you the cascading effects across the whole value chain.
That's a really powerful framework. It treats the organization like a single complex organism. Okay, so for our listeners who are maybe more technical or who need to convince their leadership, let's get into the mechanics. How does the model go from those 5 domains of data to a single actionable instruction? Let's unpack that 6-step reasoning chain.
This is critical, yes.
Yeah.
This is the engine that powers the whole thing. So, step 1, situation assessment. First, the model's job is just to diagnose. It looks at all the data from those 5 domains and identifies the gap between where you are and where your business objectives say you want to be.
So it frames the problem. Is this about risk or is it an opportunity?
Exactly. It figures out the specific nature of the decision needed. This filters out all the noise and focuses the analysis.
Okay, step 1 is assessment. Then what?
Step 2, option generation. Now, given that problem, the model doesn't just look for one answer. It intelligently generates a whole range of different feasible actions.
So it's brainstorming.
It's like AI-powered brainstorming. Maybe one option is the cheapest, another's the fastest, and a third is the one with the lowest long-term risk. And make sure you're not stuck with just one path.
Okay, so you have a set of options. Step 3.
Step 3, outcome projection. This is where the AI twin really becomes that virtual laboratory. For every single option it just generated, it runs a simulation to predict the likely outcome.
And this is where the heavy-duty math comes in.
This is where it gets very technical, yes.
Yeah.
We use a hybrid of deterministic models for things with clear dependencies, like if you schedule maintenance, this production line stops. But we also use stochastic or probabilistic models for things with uncertainty.
Wait, stochastic. So it's accounting for random chance or uncertainty.
Precisely. Like, how likely is it that supplier X will be reliable over the next 3 months, given market volatility? It's not just one fixed prediction. It's a range of probabilities with confidence intervals.
So it's not just saying this will happen. It's saying we predict a 5% increase in throughput with a 90% confidence level.
Exactly. It quantifies the prediction. And that leads directly into the next step.
Which is?
Step 4, risk analysis. It's not enough to know the upside. You have to quantify the downside. For each of those paths, the model identifies and quantifies the risks. It might say option A saves money, but it makes you reliant on one supplier, giving it a 30% risk of catastrophic failure in the next 6 months.
Whereas option B is more expensive but diversifies your suppliers.
And lowers that specific risk to 5%. It's constantly measuring the downside volatility against the expected gain.
Okay, so you have outcomes, costs, and risks all quantified. What's step 5?
Step 5, prioritization. Now it takes all of that information and ranks the options. And this is key. It doesn't rank them based on some generic score. It ranks them dynamically, according to your explicit business objectives we talked about earlier.
So if the company's goal this quarter is to avoid risk at all costs,
Then option B, the safer, more expensive one, goes straight to the top. If next quarter the goal is aggressive profit growth, the ranking flips and option A becomes number 1. It forces your actions to align with your strategy.
and that brings us to the final step, the actual recommendation.
Step 6, action specification. This is the payoff. The highest ranked option is translated from an idea into specific, unambiguous, implementable steps. It's not advice, it's an instruction.
Give me an example of an instruction.
Delay the start of batch 4 by 40 minutes and reallocate resources 1A and 1B to line 7 maintenance immediately. It's designed so a frontline operator can execute it right away, or it can be fed directly back into an ERP system.
That is the very definition of prescriptive intelligence. But you mentioned this is dynamic. What happens after the action is taken? The real world isn't always predictable.
An excellent point, and that's where the continuous feedback loop comes in and closes the whole intelligence cycle. As soon as the action is executed, the AI twin starts watching the real-world outcome
It measures what actually happened.
meticulously.
Right.
Did we actually get that 5% throughput increase, or was it only 3%? If there's a difference between the prediction and reality, the decision intelligence models use that new information to immediately refine themselves. They adjust their parameters. They correct their predictive logic.
So the system literally learns from its own experience, from its own successes and failures.
Yes, every single decision makes the entire infrastructure smarter, specifically about the unique quirks and constraints of your organization.
And it really compounds the value over time.
It's the engine of that compounding institutional knowledge. And that really underscores the exclusivity factor.
Yeah.
Because these models and this whole self-refining process are proprietary to Twin Labs, they build a knowledge base that a competitor using some generic AI tool just can't replicate. It's a self-optimizing capability that is the real game changer.
Okay, let's pivot now from the really sophisticated architecture to the tangible value. For the listener who's thinking, okay, so what? This idea of a consequence-free virtual laboratory, the strategic simulation, that has to be a huge deal.
It fundamentally changes how you think about strategic risk. I mean, historically, if you wanted to make a big change, launch a new product, build a new factory, it involved massive sunk costs before you even knew if it would work.
It was high-stakes trial and error, or as you said earlier, analysis paralysis.
Right, you spend 6 months modeling it manually in spreadsheets. Now you can test a multi-million-dollar strategy inside a simulation that runs in, minutes or hours, not months.
The ability to iterate that fast with no real-world risk must be invaluable.
It is. Think about a big company trying to meet a sustainability goal, say, cutting energy use by 20%. Instead of just jumping in and committing capital, they test it in the AI twin first. The simulation can immediately project the trade-offs.
Like what?
Like, how will that 20% reduction impact your production throughput? Where are the unexpected bottlenecks going to pop up? How does it affect the wear and tear on your equipment? It gives you a quantified, projected outcome and a clear roadmap before you spend a dime.
And it finds those unexpected consequences, which is where these big projects usually fall apart. Beyond strategy, what about day-to-day risk management? This sounds like we're moving from just reacting to fires to actually seeing the future.
It is absolutely a shift from crisis management to strategic calm. Most risk management today is just based on thresholds. An alarm goes off when a KPI drops below a certain number.
It's reactive.
It's totally reactive. The AI twin's proactive risk management is different. It's looking for subtle patterns of combined events that signal an emerging threat that no single KPI would ever catch.
Okay, give us a few examples of those subtle below-the-radar patterns.
Sure. One could be the convergence of a few seemingly minor things. Let's say you have a 5% increase in a machine's thermal output, a 3% dip in the consistency of a raw material you're using, and a recent uptick in staff overtime.
Individually, none of those are setting off a big red alarm.
Exactly. They're just minor deviations. But the AI twin, because it understands the constraint networks, recognizes that this specific combination has, in the past, preceded a major, very expensive component failure within the next 45 days.
So it sees the systemic vulnerability before any single alert goes off.
Yes. Another example is in the supply chain. The model might see that even though you buy a critical spare part from 20 different global suppliers, 80% of those parts all pass through one specific shipping port.
A hidden dependency.
A hidden dependency. And if that port is in a region facing, say, political instability, the twin surfaces that systemic risk. It tells you to diversify your logistics path or increase your inventory now before the port actually closes. It lets you solve problems calmly instead of scrambling when disaster strikes.
That's incredibly powerful. It's not just the risk of a single part failing, it's the correlation of risks. But what about in the moment, minute by minute? Does this guidance come in a long report, or is it truly real time?
It has to be real time, have to be continuous and dynamic because business doesn't stop for a quarterly review. The system is designed for real-time decision support. If something critical happens, a key supplier's factory shuts down, or a storm takes a distribution center offline, the AI twin immediately reevaluates everything and generates an optimized plan to mitigate the damage.
Okay, give me a rapid response scenario.
Let's say a critical piece of equipment in a factory that's running at 98% capacity just unexpectedly goes down.
The traditional response is panic.
Panic and follow a fixed procedure from a binder. The AI twin, in seconds, assesses the current orders that need that machine, the cost of an emergency repair versus shifting production to a less efficient machine, the impact on delivery promises, and the cost of overtime staff. It maps out the single least disruptive path forward.
And it gives you an instruction.
It gives you a clear instruction. Shift all urgent orders to line 4, delay the start of line 3's less critical batch by 3 hours, and notify these 4 specific customers with a revised delivery window. The decision is instant and fully contextualized.
That clarity, that speed is a massive operational edge. Okay, let's make this even more real. Let's go through some specific, authoritative industry examples. I want to hear exactly the kind of sophisticated recommendations these models generate. This is where we see the difference between generic advice and real intelligence.
Agreed. Let's do 5 detailed use cases. Start with manufacturing. The challenge here is always balancing complex schedules, expensive machinery, and volatile energy costs.
Right, so what's a concrete recommendation a manufacturer might get?
Okay, so the AI twin might look at energy price forecasts, component reliability data, and the order backlog, and issue a really layered recommendation, something like delay the 2.8 nano-PM batch start on line 2 by 40 minutes to avoid the 15% spike in peak electricity rates we see coming. Use that 40-minute window to do the scheduled maintenance on line 3. Also, increase the buffer stock of component X by 12%. We'll put in the assembly area, not the receiving dock, because we know supplier D's reliability drops in Q4.
Wow, so that's a single directive that optimizes energy, maintenance, and internal logistics all at once.
That's the holistic view.
Okay, let's move to healthcare. The complexity there is all about managing people and unpredictable patient demand.
For healthcare, the AI twin can model everything from ER flow to how resources are used. A powerful recommendation would be about proactive staffing. For instance, increase ICU staffing by 2 registered nurses and 1 respiratory therapist for the Thursday night shift, from 10:00 p.m. to 6:00. This is based on integrating recent seasonal admission patterns with local public health data. At the same time, schedule all non-urgent elective surgeries for Tuesday mornings, because that's when the imaging department historically has the most capacity.
So it's anticipating the peak demand before it hits and overwhelms the staff.
It's anticipatory management.
Next up, urban planning and smart cities. Here, the decisions lock in outcomes for decades and involve huge sums of public money.
And here, the AI twin acts as a massive simulator for the city. It lets planners test big, expensive infrastructure projects against smaller, cheaper policy changes. The power is in quantifying those trade-offs.
So what would a recommendation look like?
It might present a complex choice. Something like, the proposed light rail extension will cost 300 million rand and is modeled to reduce road congestion by 18% over 5 years. Alternatively, implementing adaptive traffic signals on the eastern corridor costs only 45 million rand and will give you 70% of that congestion relief. The model recommends prioritizing the traffic signals now and reevaluating the rail project in 3 years based on the new traffic data.
That provides the hard evidence to make a smart budget decision, even if there's political pressure for the big, flashy project.
Exactly. It's data-driven governance.
How about energy and utilities? They're constantly dealing with weather, shifting demand, and keeping the grid stable.
An incredibly complex and critical sector. The AI twin models the entire grid generation, transmission, demand, and renewables. A recommendation here would integrate maintenance, load balancing, and market pricing. For example, increase reserve generation capacity by 8% for Tuesday afternoon, as weather forecasts show a 15% higher cooling demand peak coming in Zone 3, and schedule the non-essential maintenance on the Zone 4 substation for next Thursday when demand is projected to be low to avoid paying higher market rates for replacement power.
It's dynamic grid management driven by predictive intelligence. Okay, last one. Logistics and supply chain, a sector pretty much defined by global complexity and chaos.
This is a space where the AI twin really shines. It can guide everything. And the example from the source material is super detailed, it might say. Increase inventory of product line A at the Cape Town warehouse by 30% now, ahead of the seasonal demand surge we predict in 3 weeks. Immediately shift 15% of Eastern Cape deliveries from Carrier B to Carrier C because B's on-time performance has just dropped by 5%. Also, consolidate Wednesday's shipments from Distribution Center 5 to save 12,000 Rand a week in transport costs.
The level of granularity in that is just incredible. It's not a suggestion, it's a detailed operational plan.
And it ties every operational shift directly to a quantified financial outcome or a specific risk being mitigated.
The power in all those examples is how specific and multifaceted they are. They're not generic at all. Okay, so we've established that the decision intelligence models are the core, but let's talk about the tech that supports them. We hear this term, agentic AI. What does that actually mean?
Agentic AI is really the backbone that enables this level of dynamic reasoning. It's very different from traditional machine learning or simple automation. A traditional system just runs a fixed algorithm. Agentic AI uses what we call autonomous software agents. Think of them as little entities that can reason, learn on their own, and self-correct.
So if a traditional system is like a calculator, an agentic AI is more like a junior partner who can make judgment calls.
That's a great way to think about it. And for that junior partner to be effective, it needs 3 things: memory, planning, and tool use.
Okay, break that down in the context of the AI twin.
Sure. The agentic AI has memory, so it remembers the results of its past decisions. That's the feedback loop we talked about. It has planning ability, so it can break a big goal, like minimize risk next quarter, into smaller steps. First, check inventory. Second, project failure rates. Third, evaluate new suppliers.
And tool use, that sounds important.
It's critical. The agentic AI isn't stuck in its own little world. It can autonomously go out and use other systems and applications. It's tools. For example, an agent sees the sudden market signal. That's tool 1, an external data feed. It decides it needs to shift inventory. So it goes and queries your ERP system tool 2 for current stock levels and your warehouse management system tool 3 for resource availability. It uses that live data to make its recommendation, and it can explain why based on the data it pulled. That autonomous goal-directed reasoning is essential.
That explains the how, but the whole system is only as good as the data it's fed. Let's talk about the data integration. This has to be a huge challenge connecting all these different siloed sources.
It's the foundational challenge. To get an accurate model, you need a single, unified, real-time view of reality. And that means integrating data from 4 very different streams.
What are they?
First, you have IoT devices and OT systems. This is all the real-time streaming data from your machine, your sensors. The challenge there is just the sheer volume and speed of it. Second, your enterprise systems. Your ERP, your supply chain management system, your CRM. This is all your transactional data. The challenge there is that the data is often messy and lives in different departmental silos that don't talk to each other.
The classic problem.
The classic problem. Third, external contextual sources. Weather feeds, market prices, regulatory updates. This data is often unstructured and has to be fused with your internal data. And fourth, your historical repositories. Years and years of cleaned up data that the models need to learn patterns. The platform has to do the immense technical work of pulling all of that together into one unified view. Without that, the AI twin is just a nice idea.
So once you've done all that work and processed all that intelligence, it still has to be usable. So often AI fails because the output requires a data scientist to interpret it. How does Twin Labs make sure this is actually business-ready and accessible?
That is a core design principle. Sophistication has to come with simplicity. The interfaces, the dashboards, they are built for the operations manager, the frontline supervisor, the executive, the people making the decisions. They don't need to see the math. They need the answer.
So what do they see?
The dashboards really do four things. First, show the current state, a simple graphical snapshot of operational health. Second, trend and predictive analysis, not just where you are, but where you're headed. Predicted capacity strain in 2 weeks. Third, and this is the main interface, prioritized recommendations. It shows you the top recommended action along with the predicted outcome. Do this, and we project $50,000 in savings with 95% certainty.
And the fourth?
A scenario comparison sandbox. This lets a manager interact with the twin. They can pull up option A and option B side by side and see a direct comparison of the projected outcomes, costs, and risks. It empowers them to make the final call with confidence.
That focus on clear answers is what drives adoption. Okay, let's talk about the business model. How is this intelligence actually delivered to different kinds of companies?
Right, a mid-sized company has very different needs from a giant enterprise. So they offer 4 different ways to engage.
What's the first one?
Number 1 is a SaaS platform, software as a service. This is the fast option. It's a subscription, runs in the cloud. The benefit is a lower cost to get started. You get all the continuous updates, and it's scalable. Perfect for a mid-sized company or a single department that wants to run a pilot.
Okay, what about the big players?
For them, there are custom enterprise solutions. This is for large organizations with really complex mission-critical systems. It's a deep partnership to build a totally bespoke AI twin that's fully embedded into their architecture.
And you can't just drop the tech in and walk away. There's a human element.
There is, which is why the third offering is strategic consulting and enablement. This is about the organizational transformation, training staff, adapting processes, managing the change. This part ensures the company actually gets the full value from the AI instead of just having some fancy software nobody uses.
That's critical. And the last one?
The last one is API access. For tech-forward companies that want to build their own applications on top of the intelligence layer, this gives their developers the tools to integrate the decision intelligence directly into their own in-house platforms. Maximum flexibility, but it requires a lot of in-house expertise.
That's a really comprehensive approach, covering everyone from a quick start subscription to deep, bespoke consulting. Okay, to bring this all together, let's really synthesize the strategic positioning here. Let's go back to the core competitive advantage. If another company comes along and says, we have a digital twin, what is the fundamental reason they can't match this capability?
The unmatched advantage, and it's worth saying again, is the proprietary decision intelligence models. Competitors can build a mirror. They can give you descriptive analytics, but they can't easily replicate that exclusive contextual reasoning layer, that 6-step chain that integrates your strategy, quantifies your risk, and turns all that complexity into a specific, measurable action. Twin Labs has spent years perfecting that prescriptive layer.
The layer that answers, what should we do next?
That singular focus on a business-ready recommendation is the strategic wedge.
And it's a wedge designed for the decision maker, not the data scientist, which has to speed up the whole process.
Absolutely. By giving clear answers, you eliminate the need for a translation layer. An ops manager doesn't have to go ask a team of analysts what the dashboard means. This simplicity is so important for getting quick adoption and showing a clear, fast ROI. It changes the conversation from, did the model work, to what was the measurable outcome of the action the model gave us.
Okay, one final point we have to address is their origin. They're based in Durban, South Africa, in a global tech market. What's the strategic value of that local expertise operating at a world-class standard?
I think the Durban base for Twin Labs gives them a really unique and valuable perspective. When you operate in dynamic, fast-evolving markets, you're often dealing with, resource constraints, infrastructure that isn't always perfect, and sudden volatility. That forces you to engineer your solutions with resilience and adaptability baked in from the start.
It breeds certain strengths.
It does. Things like adaptability, building systems that work well even with imperfect data, resource efficiency, getting the most predictive power out of the least amount of hardware, and a huge focus on practical, pragmatic implementation that delivers real results in messy, real-world conditions.
So they're building solutions that have been tested in really demanding environments, which means they're going to be incredibly stable and resilient for any client anywhere.
Exactly. That kind of hard-won operational resilience, when you combine it with a high-performance, cloud-native architecture that meets the highest security standards, that's a really compelling combination. And their ability to apply what they learn across industries, from manufacturing to healthcare, just adds to their credibility and makes them a reliable long-term partner.
The story here really is about transforming a company's data infrastructure from being a cost center that just reports on the past into a strategic intelligence asset that helps you execute the future. This deep dive has really shown, I think, a fundamental transformation in how we should be thinking about enterprise technology. We're moving away from that reactive model of, waiting for something to break and then analyzing it.
And moving decisively to a proactive, strategic execution model.
And that's achieved by embedding this proprietary intelligence right at the core of your operations. Intelligence that doesn't just predict what might happen, but actively guides you toward the best possible outcome.
And this is the final critical piece, that proactive execution is measurable. The last step in the infrastructure is quantifying the value. They don't just recommend an action, they track the actual outcome, compare it against the prediction, and give you clear metrics. Reduced downtime, verified cost savings, a hard ROI on the intelligence itself.
It closes the loop.
It closes the loop and it validates the entire strategic investment.
That focus on measurable value is probably the strongest argument of all.
So as we wrap up, let's just leave you, our listener, with a final thought to chew on. In a world where complexity and competition are accelerating every single day, the competitive edge, it no longer goes to the company with the most data. It goes to the company that can turn that data into better, faster, and more measurable decisions. So ask yourself this. If your organization's investment in AI doesn't end with a specific measurable action that you can track and quantify, how are you really measuring its success? The future of strategic advantage is in prescriptive, actionable intelligence. Thank you for joining us today. Visit the Twin Labs website for more business insights.